This is not an in-depth tutorial on how to configure all aspects of an emitter. Rather, it shows a general pattern of duplicating elements of the MACE entity hierarchy, platform, equipment, emitter, and so on, and then using a mission to make live edits to an emitter to achieve the desired capabilities before oversaving it. There are more details in the emitter editor manual and in our videos on our YouTube channel that explain how to make an emitter from scratch. There are more details within the Mission Object Configuration Tool MOCT manual and videos on our YouTube channel about editing the other aspects of platforms and equipment XMLs and the other XMLs such as missile aerodynamic models or flight models and the like. Here's an overview of the model hierarchy. With the platform at the top, a platform can be equipped with equipment which can be placed on or not on a hardpoint. And platforms can be hooked up to models, such as aerodynamic models or a model of the radar cross-section of a platform, as can equipment. A bullet would need a ballistic aerodynamic model, and a missile would need a missile aerodynamic model. Today, we're just going to look at what it takes to duplicate a platform, a piece of equipment, and to edit its emitter model. We start by opening the Mission Object Configuration tool. We're going to duplicate a similar platform, in this case a search radar. I use the filters to search by name. Before I duplicate it, I can open up the platform and see what equipment and associated emitters are fitted to it. To duplicate the platform, I right-click at the top level and select Duplicate Platform. When we duplicate a platform and save it, it gets saved into the user data folder of the platform's XMLs. This means it won't be overwritten by subsequent installations of MACE. This means I'm free to make as many mistakes as I want and always be able to go back to the original platform. I'm only going to change a few parameters here. Just going to comment for other people who might want to edit the platform. And I'm going to rename it something sensible. I'm also going to change one digit in the DIS enumeration. In reality, if I was working on a DIS network, I should check the Simulation Interoperability Standards Organization documentation and put the correct enumeration here. But as this is just a test, I'm happy to leave it. I'm not going to change any other parameters about the platform or edit any other linked XMLs to the platform, such as its movement model or the visual model in the image generator or anything like that. I'm now going to save the platform and close the platform editor pane. I'm going to do a very similar process with the equipment. I've selected the equipment tab and I'm going to search for that piece of equipment that was on our platform. Once I've found it, I can open it up and make a note of the associated device, which is the emitter that we're going to edit. I duplicate the equipment just like I duplicated the platform by right-clicking. I'm putting a comment in and renaming it. And I don't really need to do anything else on this equipment XML other than delete the associated emitter once I've made a note of it. I do that by right-clicking on it and selecting delete. I'm now going to open up the emitter editor. I can open up this tree to list all the emitters in MACE and find the name of that emitter I made a note of earlier in the equipment. I can copy the emitter by right-clicking and selecting copy, then select the user data folder and paste as a new device. Now I can go into the device at each level and change every name where it mentions the previous emitter name. Also change the maximum range here. This is the range at which beyond it will not assess signal returns. Continue to change the names at each level. I don't need to change the name of the modes. And we're going to look at this very similar emitter editor in MACE in the live mission. Once I've changed all this, I need to save it. So I right click and save the device as, which will open up the user data folder, and I can choose a name. When I close the emitter editor, it'll ask me if I want to create a piece of associated equipment. I don't need to because I've already duplicated a piece of equipment and named it. So back in the MOCT now, on that piece of duplicated equipment, I can add the associated emitter just by right-clicking on associated devices, add, and pick it from the list. So now it's time to add that new piece of equipment to the platform. So I go back to my platform and find it in the list. And then I need to delete the original piece of equipment and add my new piece of equipment, which I renamed. That piece of equipment will be added with its associated emitter. Once I've saved that, I now have a platform with a new piece of equipment, and that new piece of equipment contains my new emitter. And now I can open MACE and start adjusting the emitter parameters and configuring it to the capability I want within a live mission. In MACE, I'm going to do some basic mission setup so that we can adjust the parameters of our emitter. I'm just going to zoom in on Scotland here, opening the mission builder and finding our new demo radar platform and putting it on the map. I'm using the snap to high point tool to get it onto the highest piece of ground within 10 nautical miles. That's because the range I'm experimenting with, which is about 500 kilometers to see over the horizon, I'd need it to be elevated quite a bit for this. I'm just going to add a sector operations center, or a CRC, a blue one, and we can see that they've linked together with the IADS TDL radio. That means that this can now operate and pass tracks, and if I was to add other radars, it would be able to pass tracks between them. But by adding that sector operations center, it means it will just operate automatically in the mission. I'm now opening the mission rehearsal tool on the radar, which we're going to use later to see just how far its radar will propagate. I'm opening the weapons and equipment on the platform itself and opening that radar piece of equipment and selecting the sensor tab so I can see what targets it can see. And I'm opening the EW editor on that platform to show what emitters are on there, of which our radar is listed, so that we can live edit the parameters, and when we're happy, eventually save it back over the top of our user data folder. And finally, I'm just opening platform properties on the platform and adding a range ring, which is the range I've decided I want to configure my radar to, which is 500 kilometers, which it automatically transforms into nautical miles. I'm zooming out now so I can see the intended range of my new radar, indicated by the blue range ring. I've already previously worked out that my incoming aircraft would need to be up at about 42 to 45,000 feet to be detected at that range due to the curvature of the Earth. I'm just checking that by using the mission rehearsal toolbox I opened earlier to check line of sight at that target ingress altitude. I've increased the drawing range to 270 nautical miles, which is just over the 500 kilometer target range. My line of sight plot confirms that it is possible to see an aircraft at that altitude at that range. So now I'm going to add aircraft so that we can see if our radar can detect them at the various different ranges and settings we set. I've added a generic tanker aircraft. The reason for that is because it has a single number for its average radar cross-section, whereas some of our other aircraft have complex 3D radar cross-sections. While we're editing parameters, I want to run that simply against a known radar cross-section that isn't going to change. I've used the initial aircraft's waypoint to point it towards the receiver. I am also going to add a smaller fighter aircraft, which I know to have a 3D radar cross-section file loaded, so that we can see how that works out later on with our emitter. Likewise, I'm using that single waypoint to point this aircraft towards the new radar. I'm just going to show you what I'm talking about in terms of the radar cross-section by opening the emitter editor on the generic tanker aircraft. At the top level, if I click on the RCS tab, you can see there's no 3D picture here in either of these two black areas, and that we're just using an average RCS value which we can find in the Entity Data tab. This is really useful because we can adjust it to see how our radar performs against different RCS values. Just for contrast, if I open the emitter editor on the other aircraft and go to the RCS tab, we can see a complex 3D radar cross-section file is loaded on this aircraft. Back on my new radar, I'm selecting the platform and I'm giving it the target of the generic tanker. And that's for use with the mission rehearsal tool, radar propagation plot. We can actually have that do a radar propagation plot against a specific RCS of the allocated target without having to keep typing in different RCSs. And one last thing with the platforms, I need to put them up at that higher altitude so that they can even be detected by our emitter. So I'm just raising their altitude now using the entity controls. Now on my mission rehearsal tool for the radar platform that I opened earlier, on the radar tab, I can now select a selected target tick box, which will now automatically fill in the radar cross-section value for the target that we already selected from the radar, which in this case is the generic tanker, and then I can draw the radar propagation plot. If the target falls within the green area, it is theoretically possible to detect a target of that radar cross-section if it falls within the beam volume. Now we can start the mission and configure our emitter whilst it's running. I can see from the radar device properties form that I opened from weapons and equipment that it is scanning for targets. However, it's not currently picking up any targets, so we need to look at the emitter parameters and make some adjustments. Switching to the emitter editor for the platform and selecting our demo radar emitter type, I can see that it has a reasonable scan pattern, but we could make adjustments to that to change its period, its pitch and amplitude. But I'm going to make my adjustments to the beam shape. I have a plan view and side view here. I'm adjusting the side view shape of the beam to a square shaped beam with a much higher beam volume. And as soon as I do that, you can see in the radar device properties that it's now detected our generic tanker. The scan pattern tab now shows that larger beam width moving in its scan pattern. I can slow the speed of the scan down so I can get an easier idea of what the actual scan pattern is. In the mode data tab, I can change the power emitted from the transmitter and also things such as the sensitivity of the receiver, amongst other factors. I can also open the EW devices on the target aircraft itself and reduce its radar cross-section, as we're just using that single average RCS figure for the simple aircraft, and see how our radar fares against that. It's still able to detect the smaller radar cross-section of 10 meters. And we can see the mission rehearsal tool radar propagation plot automatically adjust to the new value. Now I'm going to edit some of the power values for our new radar. I can adjust any value in this mode tab, but I'm going to adjust the peak power and average power values, and perhaps the sensitivity value of the receiver. On the right hand side, it will show us our theoretical max range for the radar. If I once again adjust the radar cross-section value of the target, this time lower, we can see that we're now sitting right on the edge of the detectable range for a target of that radar cross-section and for our new power settings. Although we've got the range ring, it can be quite useful to have a dynamic range and bearing tool line paired between the platform and the target so that we can see at what range the detection actually occurs. And in this way I can just make further adjustments to the mode data settings until I get the configuration I want for my radar. This looks like just about the right setting to detect the aircraft at around 500 kilometers. You can also see a Link 16 marker underneath the aircraft, which has now moved onto the aircraft once it's been detected by the radar. The reason for this is because I've equipped the radar itself also with a Link 16 radio. The original radar that we copied had that radio and I left it on. Because it has that Link 16 radio, it's able to create and pass tracks within its track processor out to other Link 16 equipped platforms. We can continue to iterate in this simple way with the power settings, but they do depend on other things such as the pulse parameters and other settings that you can set within this emitter editor. This is not a detailed tutorial on configuring emitters, but more a general process of how you can use a live mission to do this. For detailed information, there is a tutorial video on creating an emitter from scratch, and there is also the MACE emitter manual that you can use to get more information. Now adjusting the sensitivity of the receiver itself obviously makes a change to the range at which we can detect certain entities. Once we've done that with the simple generic tanker entity that only has the single figure for its radar cross-section, we can just target the more complex fighter platform with its 3D radar cross-section and see how the plot looks for that as we turn the aircraft in different directions and its radar cross-section that is actually seen by the beam that's hitting it changes in relation to its aspect. Once again, we can see as detection occurs with the radar, because it's equipped with the Link 16, the enemy aircraft is assigned with the red doghouse tag surveillance track, which would be passed to any other Link 16 enabled aircraft that was within range of that transmission from the Link 16 radio. You can make a visual assessment of the beam parameters by using Armor and the MACE Beam Viewer plugin. This is especially useful for seeing the shape of the beam and scan patterns. With Armor up, I press B to activate beams, but I need to use the MACE Beam Viewer plugin to show those beams in Armor. I can actually select the radar cross-section here in the Beam Viewer plugin, which means the extent of the beams, if the beam scale multiplier is 1, will be the detectable range of the radar. I've turned off all but the early warning radars so as not to cloud the view in Armour. With the beams on in Armour, I can see the shape of that search radar beam and now make adjustments on the fly and see what difference it makes to the beam shape in the 3D environment. I can also make adjustments to the scan pattern, such as its starting elevation, its rates, and its period, and see what difference that makes to my scan in the 3D environment. In fact, I can make adjustments to pretty much any parameter and see what effect it has on the detection range of the beam in that 3D environment. Because I've got the correct radar cross-section values put into the beam viewer, I can maneuver the view to see where the beam volume actually intersects incoming targets. The important thing to remember here, though, is these changes are being made locally until we oversave our user data. We do that by right-clicking on the emitter within the emitter editor and selecting Save As, and then overwriting or saving a new emitter in the user data folder.